Hello everybody and welcome to this video, which is another Unit 8 volume video. Okay, so we have y equals sine x, which is this orangish function here. We got cosine x, which is the light blue. We got x equals 0 as a bound, so maybe I should put that there. There we go. And we have x equals pi over 4 as a bound. Okay, now, I have all this experience, so I know that sine and cosine meet at pi over 4. So just, make sure that you understand that. And then, of course, the x-axis is a bound. So, awesome. So we're going to, so first we need to find our region. Okay, so the region bounded by all of these. Okay, so that's going to be right here. Okay, that is our region. And then what we're going to do is we're going to take this region and we're going to spin it around the x-axis, not the y, so not this way, the x-axis. Okay. So yeah. So let's try to imagine what that's going to look like. Yeah. So first, if I just rotate this area, so this right here, the green, this is what I will get if I integrate cosine. Okay, and if I integrate sine, I will get the yellow and the green together. Okay. Once again, if I integrate just cosine, I get the green region. If I integrate just sine, I get the yellow plus the green, and we don't want either one of those. We want just the yellow. Okay, so we're gonna subtract the green out. Okay, so we're gonna integrate sine, we're gonna integrate cosine, but then we're gonna subtract. Okay. And that's going to give us the yellow region that we want. Okay, so in other words, what I'm saying is this. The area, the yellow region, is going to be the integral from 0 to pi over 4, and it's going to be the top minus the bottom. It's going to be sine minus cosine. So this is just kind of a little review of area between curves. Okay, that will give us the area of that yellow region. Okay, now what we want is actually something a little different. We want the volume of this thing when we spin it around the x-axis. Okay, now again we have two curves here. Okay. So we need to keep that in mind. So in other words, there's going to be, when we spin this whole thing around, okay, there is going to be an outer radius, which is going to be this one, okay, and then there's going to be an inner radius, which is going to be this one, okay. And what we want to do is we want to basically, kind of like we did here, we want to find the volume due to the outer radius, find the volume due to the inner radius, and then subtract the two, okay? We got to be careful, though, okay? We have got to be careful, all right? So, so basically, the volume is going to be the integral of the area function, and in this case, it's in terms of x. Okay, now the area that we're talking about here, remember we're spinning it around. Okay, so this is going to be integral, and then it's going to be pi r outer squared. Okay, this is going to be the volume due to the outer radius, minus, and then r inner squared. Okay, when I integrate this, that's going to give me the volume of the inner radius there. Okay, so when I subtract the two, I just get the volume of the yellow region. Okay, all right. So this is called the washer method, volume by washer. Okay, and now so let's actually do this now. So this is going to be integral, and then it's going to be pi, and then r outer. R outer is the sine function. No, no, it's not. R outer is the cosine function. Sorry about that. So we get cosine squared, and then minus pi, and then sine squared. I do apologize for that mistake, because I know now that this, the one up here, the area, oh, no, we're, okay, wait, no, okay. Yeah, so this should actually be, yeah, this should be flipped. This should be cosine minus sine. Sorry. Okay, so once again, sorry for that, okay? Top minus bottom. The top is the cosine, which is in blue. The bottom is the sine, which is in the orangish color. Top minus bottom. That's going to give us the area of the yellow region, okay? That's that. But now we're down here at volume. So we're going to take this yellow region and we're going to spin it around the x-axis. And that is the computation that we have here, okay? So pi cosine squared minus pi sine squared. Very good. So both of these contain a pi. So I'm going to factor the pi out. Pi integral. And we're going to be left with cosine squared minus sine squared. Okay, now normally this integral would be pretty hard because you have a cosine squared and a sine squared. But if we remember the double angle identity for cosine, remember this is actually the cosine of 2x. Okay. Very cool. And let me once again just make sure I didn't screw up. I think I'm good. All right. Okay, so now where are we integrating from? We are integrating from 0 to pi over 4. So this is going to be pi. And now if I integrate cosine 2x, I am integrating to a non-co, so it's going to be positive. So I get sine 2x. And I'm going to divide by 2. Chain rule in reverse. Okay. So there we go. There's that. And now we're going to evaluate from 0 to pi over 4. Okay. So we basically get pi over 2 as a constant on the outside. And then we're going to have sine of 2 pi over 4. Sine of 2 pi over 4 is the same thing as the sine of pi over 2. And then minus the sine of 0. Okay. And so there we go, pi over 2. And we're multiplying by 1 minus 0. And that just gives us pi over 2. All right. And let me consult with the textbook here. Did we get that one right? Did we get that one? Yes, we did. Pi over 2. We are good to go. All right. So anyway, good. We got the answer. We got a little sketch here. And notice something important here. So when we're doing area, when we're doing just the area here, we're just going to do integral top minus bottom and call it a day. Okay? Now, when we're doing washer, volume by washer, okay? Notice we are not subtracting first. We are squaring first, then subtracting, okay? This is a huge pitfall for beginners, okay? So please be careful. Do not subtract and then square when you're doing the washer method. square the outer, multiply by pi, square the inner, multiply by pi, then subtract, then integrate, okay? So be very careful about that. All right.